Hello Year 11. Today we're going to look at what we mean by the rate of a chemical reaction. Now before we do, I'd like you to go and get pen and paper and find yourself a nice quiet room, and I will pause the video while you do that. Okay, I think you found a nice quiet room and you're ready to start learning. We're going to start our lesson the way that we always do, which is with a retrieval practice. So I've got an equation here. Magnesium plus hydrochloric acid will react to give magnesium chloride plus hydrogen. I want to know what the reactants are, what the products are. And just some questions from your work in year 10. Which ion, when in excess in a substance, will cause it to be acidic? Which type of substance reacts with an acid in a neutralization reaction? And what type of bonding is present in graphite, magnesium chloride and hydrogen? And I want you to pause the video now while you answer these questions on paper and then come back when you've done it. Okay, we're ready to answer the questions now. So, the reactants are the things at the beginning of the equation, the things to the left of the arrow. They are magnesium and hydrochloric acid. All the products are on the right hand side of the arrow, which means that they are magnesium chloride and hydrogen. The ion in excess in a substance that causes it to be acidic is the hydrogen ion, the H+ ion. And the type of substance that reacts with an acid in a neutralization reaction is an alkali or a base. The type of bonding you'd find in graphite is giant covalent. Covalent because it's a non-metal. It's reacting with itself and it's forming a very big structure. So it's a giant covalent structure. Magnesium chloride is a metal and a non-metal, so that is ionic. And hydrogen is small molecule, so it is simple covalent. Hopefully you were successful in that. Okay, so our success criteria today are: we want to be able to state what we mean by the rate of a reaction. We need to be able to calculate a mean rate of reaction from the non-graphical information and be able to calculate a mean rate of reaction from graphs. So what does the term rate of reaction mean? Well, if you're talking about the rate of something, you're talking about how fast something happens. So we're looking at how fast a chemical reaction happens. The rate of reaction is defined by how fast the reactants are changed into products. So how fast would the things you begin with change into the things you are going to be making in the reaction? So, explain which reaction occurs at a faster rate. So, which of these two do you think is happening at a faster rate? Rusting or burning magnesium? So, as you can see, we've got a very big reaction with the magnesium, right? It's instantaneous. So, we're changing it from magnesium and oxygen to magnesium oxide straight away. Whereas rusting takes days, weeks to happen. So we're changing iron plus oxygen to iron oxide, and it's going to take a very long time. Okay, what I would like you to do is put an order 1 to 5 for these reactions. We're going to pause the video and I want you to say which one is the fastest, that's number 1, and which one is the slowest, number 5. So we'll pause the video and come back in a minute when you've done it. Okay, year 11, I hope you're ready now. Right, the one that goes the fastest is the thermite reaction. That's number 1. Number 2, the next fastest, is magnesium and oxygen. Because we can see some bubbles, we know it's reacting while we're looking at it. So iron and hydrochloric acid is the next one. Rusting occurs in days and weeks. So that's number 4. And chemical weathering takes years, so that's number 5. Okay, so we should now know what is meant by a rate of reaction. How do we calculate the rate of reaction? Well, just to remind you, the rate of reaction is how fast we change the reactants to products. So we can say that the mean rate of reaction, the average rate of reaction, is the quantity of product formed and how long it takes for it to form that quantity of product. So, for example, 60 centimetres cubed of carbon dioxide gas was produced from a reaction in 3 seconds. What is the rate of reaction? I'm going to pause the video for you to just think about that using the equation above and come back when you've done it. Okay, so the quantity of product formed is 60 and the time taken is 3 seconds. So we are going to divide 60 by 3, which gives us 20 grams every second. And it's very important that we don't forget the units. Now, another way that we can calculate the rate of reaction is by how much we're using up the reactant. So how quickly does the reactant disappear? We need to time it. So the equation is the quantity of reactant used over the time it takes to use it. So for an example, the mass of wood in a combustion reaction reduces by 100 grams. The mass of wood is a reactant. It takes 20 seconds. What is the rate of reaction? Again, pause the video and try and work that out. Okay, welcome back. So we had 100 grams. It's taken 20 seconds to burn it. So we're going to divide 100 by 20. And that gives us 5 grams per second. Again, don't forget the units. Now it's your turn. So I want you to calculate the mean rate of reaction for the following. The first thing I want to remind you of is to look at the units and what unit do they want the rate of reaction in. Okay, so if they're asking for something per second and the data's in minutes, you need to convert it to seconds. So on your piece of paper, please can you do these? Pause the video now and do these equations. Okay, hopefully you've been successful and you know what you're doing. Just in case you don't, I'm going to go through them bit by bit. Okay, so rate of reaction produces 20 centimetres cubed of hydrogen gas in 45 seconds. So we're going to divide the amount of product by the time. So that's 20 divided by 45, which gives us 0.44 centimetres cubed per second. A candle is burnt and it decreases by 0.70 grams when burnt for 3 minutes and 20 seconds. What is the rate of reaction? Now, the first thing that strikes me here is that you've got your time in 2 different units. So we need to convert it to either minutes or seconds, and it's much easier to convert it to seconds. So the rate of reaction is the amount of reactant divided by time. 0.7, which is the amount of reactant, divided by 200, which is the number of seconds, and that gives us 0.0035 grams per second. An elephant's toothpaste reaction released 23 centimetres cubed of oxygen gas in half a minute, 0.5 minutes. What is the rate of reaction in centimetres cubed per second? So the first thing we're going to have to do is convert 0.5 minutes to seconds, which is 30 seconds. So rate of reaction is the amount of product over time. So it's 23 divided by 30, which gives us 0.77 centimetres cubed per second. Iron reacted with hydrochloric acid to produce 7 centimetres cubed of hydrogen gas in 300 seconds. What is the rate of reaction in centimetres cubed per minute? So we need to convert 300 seconds to minutes, and that is 300 divided by 60 gives us 5 minutes. So it's 7 divided by 5 gives us 1.4 centimetres cubed per minute. Hopefully you are very successful doing that and you've passed the second success criteria. Okay, so how can we show the rate of reaction on a graph? Here you can see what we call a typical rate of reaction graph. And we're looking at the particles of reactant and products. So the white and the red particles are the reactants, and when they join together, they make a product. So as you can see at the beginning, we've got lots of reactant. So the reaction is very fast. There's a lot of colliding, a lot of reaction. Now, as they join together, there's less reactant. So therefore, the reaction's going to slow down. And at the end, we've got no reactants. So if you have no reactants, you can't have making products. So it stops at that point. Okay, so drawing a line of best fit. If you ever get a graph like this in your exam, always draw a line of best fit, because somewhere in the question it will tell you to draw a line of best fit. So why is the point at 40 degrees circled? Well, it's because it's anomalous. It doesn't fit in with the curve. It's off the curve. So it's an anomalous result. Okay, so what I want you to do now is I want you to match up the description to go with what's happening at each of the stages. Okay, so I want you to pause the video now and find out what is happening at A, what is happening at B, and what is happening at C. Okay, welcome back. Right, at A, we've got the reaction at its fastest. At B, we've got the reaction slowing down. And at C, the reaction has stopped. Okay, looking at this graph, you're often asked to look at a rate of reaction graph and interpret what's going on, like we just did with the one a couple of slides ago. So after how many minutes had all the acid been used up? So when does it start going flat? That's right, 5.5 minutes. So the student wrote this conclusion for the experiment. The reaction gets slower and slower as time increases. Explain why the reaction gets slower. Your answer should be in terms of particles. So I want you to pause the video again and then come up with your answer on paper. Okay, so what we've got is at the start, there's lots of reactant particles, but as the product is formed, the number of reactant particles will go down, the numbers of them will go down and they will decrease. This means that there are fewer reactions in a certain time, and then it gets so that there are so few reactants, it actually will stop the reactant. There are no reactant particles available to react. Okay, draw a line for the reaction that is happening at a faster rate. So what will the curve look like? Pause the video now and write down what you think would happen. Will it be above it or below it? Right. If it's going faster, it's going to make the product quicker. So the reaction curve will be above that one. But I might notice that it actually goes to the same level. It doesn't make any more product. It just makes it faster. Okay. Right, now draw one or explain what will be happening if it goes slower. Pause the video again and come back when you've done it. Okay, so if it's slower, it's making the product at a slower rate. It's still going to make the same amount, so it's still going to end up at the same level, but it is going to be underneath that curve because it's making it slower. Okay, have a shallower gradient. Right, what's happening at the start of the reaction? Is it A, no reactions happening, B, the reaction is at its fastest, C, the reaction is slow but getting faster, or the reaction is happening at a constant rate. That's right. It's B. It's at its fastest. Okay, 2 samples of marble, A and B, were each reacted with 50 centimetres cubed of dilute hydrochloric acid. The mass of carbon dioxide formed in each reaction was recorded. Explain how you can tell whether A or B reacted faster with the dilute hydrochloric acid. So I want you to pause the video now and write down your explanation. Okay, welcome back. Right, A is faster because the graph line is steeper, so it's making the product, the carbon dioxide, quicker, and the reaction stops earlier, so it's finished earlier. A is faster because the carbon dioxide is given off faster and fizzes more. Okay, so hopefully now you understand a little bit more about rate of reaction. Thank you for joining me.